Hi everyone, this is the flipping bits problem by HackerRank. The link to this problem will be in the description. So it says you will be given a list of 32-bit unsigned integers. Flip all of the bits 1 to 0 and 0 to 1 and return the result as an unsigned integer. So the example we're given a number, we're given the number 9 in base 10 format. Base 10 is just the format that we're used to working with, where we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Right, and so this 9 in base 10 format, if we convert it to a base 2 format, we get this binary string right here, 1, 0, 0, 1. And since we're working with 32 bits, we need to add zeros in front of this until the total length of this is 32. So that's how we get this really long number here. Now we flip all of the bits, so 0 becomes 1, and 1 becomes 0. And then we convert this base 2 number to a base 10 number, and we get this number right here. So the constraints for this problem is that the number of queries is going to be anywhere from 1 to 100, and the base 10 number that we're given can be 0 to 2 to the power of 32. All right, so let's take a look at our solution. Here we are. That's it. That's our solution. Nothing else to do here. Don't worry, I'll explain how this works in a moment, but let's just confirm that it does work. So let's go down to our solution. So this is our solution, right? We're returning this large number minus n. The only reason I'm putting an L is because it wants a long type, right? And in Java, this number is too big to be an integer. So it's just saying, hey, the type of number this is long, not integer. So if you're not working with Java, you can ignore the L. So let's go ahead and submit this code. And everything runs successfully. So let's try to figure out why this works. So in order to understand why this solution works, we need to understand what is 32 bits. So all data is stored in binary. 1 bit can store 2 values, 0 or 1. 2 bits can store 4 values, 0, 0, 0, 1, 1, 0, and 1, 1. The number of values that can be stored is equal to 2 to the power of n. So 32 bits can store 2 to the power of 32, or numbers 0 to this super large number here. Now what is an unsigned integer? An integer is any whole number, such as -10, -3, 0, 2, 34. An unsigned integer is any whole positive number. So if we have a 32-bit unsigned integer, that means all bits are used to store the value of the number. If we have a 32-bit signed integer, then we must use the first bit to determine whether the number is negative or positive. That means we only have 31 bits available to store the value of the number. So let's take a look at what that looks like. So this is a table of unsigned integers where we have binary and base 10, and we only have 3 binary numbers. So 0 to, we get the, with this, with an unsigned integer, we get the value 0 to 7. But with a signed integer, we get the values 0 to 3 and -1 to -4, because this first bit is used to determine whether the number is positive or negative. So how does this work? So this number, base 10, converted to base 2, remember this is an unsigned integer, it's all ones, right? So subtracting any unsigned 32-bit number from all 32 ones will flip the bits. So let's do an example where n equals 9. So we have this large number where all the bits are equal to 1 minus 9. So when we subtract the two binary numbers, the bits get flipped and we're left with our result. So how did I find this number? Well, if we remember, one bit can store two values, and the number of values that can be stored is equal to 2 to the power of n. So if there are 32 bits, then we can store 2 to the power of 32. And since we're storing an unsigned integer, all bits can be used for the value of the number. One of the values is 0. So the max value that can be stored is 2 to the power of 32 minus 1. And that is how we get this number. That concludes the solution for flipping bits. Hope that helped. If you guys have any questions or feedback, please let me know in the comments. Thank you.